So what we're going to be covering today is graphing logarithms. And as in any type of graphs, they all kind of have a similar feature. Logs look like this. They have an asymptote or an asymptote that they never cross vertically. So this is a normal graph of a logarithm with a vertical asymptote that it never crosses. It gets closer and closer. These are logs. Logs can be wide like this or they can be curved in like this. And I'm just going to go over the basics of graphing logs. Other than this course, you don't really use graphing logarithms too much in mathematics. There's a couple parts in calculus that you will be analyzing these graphs, but they're not really used too much in mathematics unless you take a specific course. I think linear or there was some random course that I took in college where I had to analyze log graphs, and it wasn't the most enjoyable course that I took. But other than this course, you're not going to really see it too much. All right, so on your notes that you should have in front of you, I say we're going to start off with graphing a basic log. Let's say y equals log x of base 5. So the way that you're going to graph this, on the notes, I say rewrite this in exponential form. Base, exponent, what it equals. And then I box this. So then just to kind of give you a little insight of how this is graphed, what I'm going to do is I'm going to create a table. Now let's say normally we would do x values and figure out the y, but logs are backwards. We are going to do the y value first because y is an exponent. So let's start off with -2. Let's do -1. Let's do 0, 1, and 2 and see where we are on this chart. So if I plug in -2 to my, I'm doing exactly what I just told you not to do. I'm plugging in for my y, -2, -1, 0, 1, 2. I'm going to plug these into my y and figure out what my x is. So starting off, if I plug in -2 into here, I get 5 to the -2nd, which is 1/25. If I plug a -1, I get 1/5. If I plug a 0, I get 1. If I plug a 1 in here, I get 5. And if I plug a 2, I get 25. All right. Now, if I were to graph this, let's start off with -2. I'm sorry. Let's go in increments of 2. I think that would be easier. So this is going to be 2, 4, 6, 8, 10. This is going to be -2, -4, -6, -8, and so on. So I'm going to graph this. I'm going to say at 1/25th on my x, which is just over, I am down at -2. At 1/5 on my x, I am at -1. At 1 on my x, I'm at 0. Look, here it is. So at 1 on my x, I'm at 0 on my y. If I go to 5 on my x, I'm at 1 on my y. So if I go to 5, I'm at 1. If this is increments of 2. If I'm at 25 on my x, boop, I'm at 2. So this is what this graph is going to look like. This is going to have a vertical asymptote of, or an asymptote of the y-axis. Because if you plug a -3, you're going to get negative, or if you plug a -3 into the y, you're going to get 1/125. If you plug a -4, you're going to get closer and closer to this but it's never going to hit this line. So here is the graph of y equals log x of base 5. This is what this graph looks like. All right, now it's asking for your domain. What's your domain? Your domain is going to be anything that's greater than 0 on the x, because it gets as close to infinity, and it gets not infinity, it gets as close to 0 on the x as humanly possible, but it never crosses or never touches the x. So anything that's greater than 0, that's your domain. Just can't equal 0. All right. Now, on your notes, I give you a little more difficult equation. This new equation that I'm going to give you is y equals 2 times log base 2 negative x minus 3. Now, this is going to be a little more complex about how we're going to do this. What you want to do is this. You want to ignore all the transformations. And let's get to the basic log before I had any transformations, which was log x, some value of base 2. Before they took a negative x, negative 3, and put it 2 times all of this. This was the basic log. This is called a parent function. So if you were to graph this parent function, let's go ahead and graph this. Let's change this to 2 to the y equals x. And I'm going to create a table now. My table is going to be and I won't mess this one up, x and y. So I'm going to plug a negative 2 into the y to get 1/4. Negative 1 into the y to get 1/2. A 0 into my y, 2 to the 0 power is 1. I'm going to plug a 1 into my y to get 2, and I'm going to plug a 2 into my y to get 4. All right, and then I'm going to graph these. So let's just go 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. I don't need to worry right now. Oh, actually, I will put this over here. I'll draw out everything. All right. So the very first thing I'm going to do is if I have a 1/4, I'm at negative 2, which is, let's just go in increments of 2 again. So this is 2, 4, 6, 8. This is negative 2, negative 4. So if I have 1/4, I'm at negative 2. Let's say let me use a different color. Say is right here. If I'm at 1/2, I'm at negative 1. If I'm at 1, I'm 0. If I'm on my 2, which is here, I'm at 1. And if I'm a 4, right here, I'm up at 2. Okay, so you see this trend. The main points that you need is this. You need more or less this, I would say this point, 1 point above in quadrant 1, and your y-intercept. These are the 2 points that I'm going to focus on. These 2 right here. All right, now what I'm going to do, because this isn't what I'm supposed to graph, but it's helpful to graph the parent function. Now what I'm going to do is on the notes, notice on the notes I say let's replace this x, and let's say y equals log base 2. Let's replace this x with a negative x. If I have a negative x, that means conceptually everything flips over the y-axis. It's just a flip. So if this point right here is going to be, do a new color, is going to be right here. This is going to be negative 1/4. I'm sorry, this point right here is a negative 1, 0. This right here was 4 and 2. This negative x means it's a negative 4 and positive 2. It still has the same vertical asymptote, so it's going to look like this, but just flipped over. I don't know, something like that. All right, here's this graph so far. Now the next step that I tell you to do is instead of negative x, we are going to change it to y of log base 2. A negative, let's say x plus 3. So technically, I am keeping this negative as a negative x, but I'm saying x plus 3. Or let's do this. Let's just do this. Let's say y equals, yeah, actually, let's keep it negative and then x plus 3. So the reason why I'm doing this is because x plus 3 is a translation. So remember, this means the whole graph, if you have a positive x and then plus 3 inside the parenthesis, it moves 3 units to the left, towards the opposite way. So this point and this point, that's why I say focus on 2 points. This is going to move 1, 2, 3 units to the left. So this point is at negative 1. This is going to be at negative 3 now. This point right here is at negative 4. Now it's going to be at negative 7 now. And what happens is this vertical asymptote moves also. Literally the whole graph moves along with the vertical asymptote. This vertical asymptote moves 3 units over to the x equals negative 3 line now. So this is going to move right here. And here's my graph so far. Notice the shape doesn't change. It just, you can technically assume it's going to go up like this. So get rid of this. Okay, now what I'm going to do is I am going to put a 2 in front of this. That means my y has twice this value. So my y equals twice this now. So if my y equaled, what is this point right here? If my y equaled 2, now my y is going to equal 4. This is going to be